come across the word congruent. What is the congruency of two triangles? Do you think our points are congruent to each other? So let us answer this question by defining what congruency is. Two geometrical figures that has exactly same shape and size are known as congruent figures. And the congruency symbol is as shown with an approximate symbol and an equal sign under that. Here we have two squares of length 5 cm and 10 cm. We know that both the figures are of the same shape but not same in size. Hence, they are not congruent to each other. Now, let us come back to this question. Are your hands congruent to each other? It is sometimes a portion is slightly bigger or smaller, and we can say that they are approximately equal. Just join both of your hands and see if they are overlapping or not. So, here we say that they are congruent to each other because of the same shape and size. Now, look at these two triangles in here. These have same lengths to each other. But do you think they are congruent to each other? Yes, they are congruent. Flip the second figure, and when you try to overlap with the first figure, it perfectly overlaps. So basically, you can turn them around, flip them, slide, move them to meet the congruency criteria. So far discussing the congruency criteria, let us directly move on to how congruency of triangles is analyzed mathematically with their corresponding dimension parameters. Now, have a look at these two triangles, triangle ABC and triangle PQR. When we look at the triangles, there is an important parameter that we have to concentrate on. We have to define which parts of the triangle is congruent. So, what we have to look is that if point A matches Q, or if point B matches P or R, and so on. So, from the figures, if you try to overlap each other by flipping, it perfectly overlaps and hence they are congruent to each other. So, clearly we can say that point C matches P, point R matches B, and point Q matches A. These points are called the vertex, which is often called so when two or more lines or edges meet. Therefore, we can write vertex A corresponds to vertex Q, vertex B corresponds to vertex R, and vertex C corresponds to vertex P. Now, looking at the angles, angle A is corresponding to Q. Similarly, angle B and C corresponds to angle R and P. Since the triangles are congruent, the corresponding angles must be equal. Now, let us look at the corresponding sides. So, here in the triangles, side AB is corresponding to the side QR. BC is corresponding to PR and AC is corresponding to PQ. Therefore, these sides overlap the corresponding sides. Therefore, even while writing, you have to write triangle ABC is congruent to triangle QRP. One cannot write triangle ABC is equal to triangle PQR. So make sure you always write them in order in accordance with the corresponding parameters. Therefore, we call these parameters as corresponding parts of congruent triangles, that is CPCT in short. And remember that corresponding parts of congruent triangle are always equal. The parts are nothing but the sides or angles of a triangle. Now, let us discuss what are the criteria for two triangles to be congruent. You cannot always pick a question from your book and then flip it and overlap it. So how do we know if two triangles are congruent without flipping it and overlapping it? So there comes the criteria for congruence of triangles. As you know, there are 6 parameters or dimensions in a triangle, that is 3 sides and 3 angles. You need not always check for all the 6 elements whether it's equal or not. We just need to check only 3 elements to conclude that if given 2 triangles are congruent or not. But it cannot be any 3 elements. So let us see what combinations satisfies the criteria. So the first criteria is that you can check whether three sides are equal or not, which we call as SSS congruence rule. The second criteria is that you can check two sides and an included angle, which is known as SAS rule. The third criteria is that you can check for one angle, an included side, and another angle, which is called an ASA congruence rule. And the fourth criteria is that you can check for two angles and a corresponding side, which is called as the AAS congruence rule. And finally, the fifth criteria is for the right angle triangle. That is, check for a right angle, a hypotenuse, and a side, which we call it as RHS congruence rule. These criteria can be well explained with examples. Now, let us discuss the same. If these three elements match for a given two triangles, then we can say that they are congruent to each other. Now, let us consider the first criteria, that is SSS congruence rule. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are said to be congruent. Now, consider these two triangles. Here, you have one side with 4.5 centimeter, which is the same as in the other triangle. Also, similarly, you have sides 4 centimeter and 3.5 centimeter, which is the same as in the second triangle. So, from this scenario, we can conclude that both the triangles are congruent with respect to the SSS rule. Basically, according to this criterion, you just need to check whether the three sides of the triangles are equal or not. Therefore, AB is equal to PQ, AC is equal to QR, and BC is equal to PR. Therefore, we can write triangle ABC is congruent to triangle QPR. When you're writing the congruency, the order matters. So make sure you write it accordingly with the corresponding sides. So we have discussed the SSS criteria of congruency of triangles. If that is the case, do you think there exists a criterion called AAA, where all three angles are equal of two triangles? Let us consider an example. There are two triangles here, each of which is 60 degrees with their respective angles. But do you think they are congruent? Their angles are the same, but they differ in their lengths, right? Yes, it does not satisfy the congruency condition. They are similar triangles, but they are not congruent. Therefore, the AAA criterion does not exist for the congruency of triangles. Now, let us discuss the second criteria, that is SAS, which states that two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Let us take an example to prove the same. In the figure, OA is equal to OB and OD is equal to OC. Let's show that triangle AOD is congruent to triangle BOC, and the second subpart is AD is parallel to BC. Let us take a look of how to approach this problem. In triangle AOD and triangle BOC, OA is equal to OB and OD is equal to OC, which is given as per the question. Also, since angle AOD and angle BOC form a pair of vertical opposite angles, we have angle AOD is equal to angle BOC. Therefore, triangle AOD is congruent to triangle BOC because two sides and the included angle is equal in both the triangles, which is the SAS congruence rule. Now, let us see the second part of the question, which says that to prove AD is parallel to BC. In congruent triangles AOD and BOC, the other corresponding parts are also equal. So, angle OAD is equal to angle OBC, and these form a pair of alternate angles for the line segments AD and BC. Therefore, we can say that AD is parallel to BC. Hence, prove that the true triangles are congruent if two sides and the included angle of one triangle are equal to the sides and the included angle of the other triangle, according to the SAS rule. Now, let us summarize the same. Two triangles are congruent if they are of the same shape and size. If two triangles ABC and PQR are congruent under the correspondence that A corresponding to P, B corresponding to Q and C corresponding to R, then symbolically it is expressed as triangle ABC is congruent to triangle PQR. And SS's congruence rule states that if three sides of one triangle are equal to the three sides of the other triangle, then the two triangles are congruent. And SAS congruence rule states that if two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then the two triangles are congruent.